Okay, how far? Uh, yesterday we stopped. Uh, Yesterday we knew what I means when it comes to complex number. We know that I is equals to the root of -1. We also learned how to extract this from something like maybe root 4. Root 4. We know that we can split it into this like this. -1 times, yeah, times 4. It will still give us negative root 4. So we'll then bring this down. uh, we'll have this that so yeah, we can split the roots using indices. So that is root -1 times root -4. We know we can still bring them back together and also get this. Okay, let's keep going. We know that -1 is I, so that we replace that with I. We'll have I times root 4, and if you join these two together, we will then have I root 4. Root 4. So that is how we can extract a that's how we can extract the root of -1 from a the root of a negative number that is not 1. So I've turned this into a complex number. Well, one thing I forgot to tell you is that a complex number is a number that has I in it. Like for instance, we can say that 2 plus 4 is a number. Like this 2 plus 4 itself is a number, because from our logical sense, 2 plus 4 is 6. So hence 6 is a number. So we can say that 2 plus 4 is 6. So we can say that 2 plus 4 is a number. But what makes this, why we call it complex number is because it has I in it. It has root of -1. So if you have something like 2 plus 3i, we can call this a complex number. First of all, we can call it a number because we know what 2 is. 2 is a number, 3 is a number, and also I is a number because we know that I is equals to the root of -1, the root of a number. The root of a number will still give you a number. So we can call this whole expression here a number. So because it now has I in it now, that's what now gave it that special name, a complex number. Let me give you another example so that maybe you can grab it better. Okay, let us say what A plus B now. Now, because they've not given you the meaning of what A is or the meaning of what B is, they never said it's a number, they never said it's somebody's name or something. A and B can be anything. They can say it's a person's name, it's a name of a team, it can be a number, but they never told us what it is. So we can't exactly say that this is a number. Because in some questions they'll say person A, person B. Sometimes they'll say the first number is A, the second number is B. But in this case, they never told us what A and B are. So we cannot say that this is a number. You get now. So what makes a number is that we know that 2 is a number, 4 is a number. We also know that I is a number because it's a root. We know that I is the root of -1. So we can we can say that this is a number. And because it has I in it, that's what will now give it that special name that we call that's what will now give it that special name, complex numbers. So let us go. So I've learned how to resolve or extract or simplify this into a complex number. So let's now recap what we did on addition, subtraction, multiplication, and division. So for addition, first of all, before we start learning addition and all those stuff, remember what I told you, that a complex number is denoted with what? A complex number is always denoted with this symbol, Z, with this cross in between. Sometimes they might just use Z. They can use anything to represent it, but it's most common in all textbooks that they use Z to represent a complex number. So let us say that Z1 is equals to 2 plus 3i. And let us now say that Z2 is equals to, let's say 4 plus 6i. Okay, there's a relationship. Let me just change this to maybe 7. Yeah. So let us now say that I told you to find Z1 plus Z2. So how do we now do this? Complex number is just simple. You just treat this like as if it's a normal unknown. So we'll just add them together. So that will be 3, sorry, 2 plus 3i plus 4 plus 7i. 2 plus 2 is what? 2 plus 4 is what? 6. 3i plus 7i is what? Just normal algebra. That is plus 10i. So therefore, z1 plus z2 will give you 6 plus 10i. Simple and short. So that is addition. Let us go to subtraction. Let us recap what we did in subtraction. Okay, why do you even clean that? Because I've just continued it. But anyways, let me rewrite it again. So we had z1 as 2 plus 3i, and we had z2 as z2 as 6 plus 7. Is it 6? No, it's 4. 4 plus 7i. So with they told us to first of all, they told us to find z1 plus z2. Now they're not telling us to find z1 minus z2. So now what is z1 minus z2? Just normal algebra. So z1 minus z2 will be this minus this. So that would be 2 plus 3i minus 4. We'll put it inside bracket to bracket, always important. 4 plus 7i. So if we open the bracket, we should have 2 plus 3i minus 4 minus 7i. So we know that 2 minus 4 will give us minus 2. Why 3 minus 7, that will give us minus 4i. Sorry, 3i minus 7i will give us minus 4i. We can even simplify it further by saying that extracting minus 2 does not give us minus 2 open bracket 1 plus 2i. But normally these are you're meant to leave your answer. So now let's move to multiplication. Let's recap what we did using the same z1 and z2. So now let's say question 3. Now they're not telling us to find z1 times z2 or z1 z2, still the same thing. So they're telling us to multiply these two. So we put them inside bracket. 2 plus 3i. Yeah, you see multiplication like this. So 4 plus 7i. I don't know if you can see this. Let me just write it. 4 plus 7i. So now to multiply, it's still just basic algebra. So we'll just use the normal multiplication, right? So let me just break it down instead of just this times this times this. So we'll just do it the normal way of showing your workings, right? So 7i plus this now multiplies this 3i open bracket 4 plus 7i. Then this open the bracket here, open the bracket here. Now we're going to give us 8 plus 14i plus 3, sorry, not 3, this will give us 12i. Now, okay, let me just continue. We'll have this times this will give us 21i squared. Let me put it inside bracket so that it will not be confusing. So this is what we have. Now remember what I told you. What is I raised to power 2? I raised to power 2 should give you what? Let's see how let's resolve it first. So we know that I raised to power 2. Since the power is even, we can just bring back this. So we'll just replace our I with this now. So that is going to give us root of -1 squared. We know that root is what? 1/2. So raised to power 1 over 2. So we'll have uh, minus 1 over 2 times 2. 1 over 2 times 2 is what? 1. So we'll have this raised to power 1. So we can just open the bracket back. We'll have negative 1. So therefore, I squared is what? Negative 1. But I'll still show you that shortcut I told you. So if in case they tend to find something like I raised to power like 10 to 4 or I raised to power 9 199, for example, they tend to find I raised to power 1000 and 1999. I'll show you that after this. So let's just finish this up first. We know that I squared is what? Negative 1. So we'll have negative 1 multiplying 21. But let's continue solving this first. So we have uh so we have 8. 8 is the only natural number that is here. We have this plus this, that's going to give us 26, right? 26i. And we now have, remember our I squared is what? Negative 2. You must cram this one. Always know that I squared is negative 1 because you'll be needing it a lot. There will be equations where they'll tell you to multiply. There will always be equation where they'll tell you to multiply when it comes to complex number. Because if you don't know, if you start doing this now, this will just add more. You'll just be wasting time in the exam also. It's better you just cram it I squared as negative 1. You can, I don't know, but just know that I squared is negative 1. So I squared is what? Negative 1. So that will turn to negative 21. So 8 minus negative 21, that should give you about negative 13. So minus 13 plus 26i. So that is it. That is z1 times z2. So now let us do more division now. Division. It's not that hard. Yeah, let me clean this too. You might be wondering, why am I using 2 rack? One is wet, one is dry. Alright, so now the last basically, the last now is z1 divided by z2. So now let's resolve that. So this divided by this. So we have 2 plus 3i all over 4 plus 7i. Now what did I tell you? What did I tell you? What's the first thing you do when it comes to division? When you have a complex number dividing a complex number, the way you do it is using conjugates or rationalization. What is it? You multiply it by the conjugate of the denominator. What is conjugate basically? Conjugate is basically you replace the sign in the middle with you get the opposite sign. Like you multiply it with the denominator. You multiply the numerator and the denominator by the denominator but with a negative, with the opposite sign that is in the denominator. Let me show you. So that will turn into 4 minus negative sign of 7i. And we'll now also do the same thing for the base too. Minus 7i. If you check, this will cancel this, this will cancel this, it will turn into 1. So we're not exactly changing the equation, we're just manipulating around to resolve it. Now I'll show you why we're doing this basically. We're basically doing this so that we can turn this denominator into just a single number without I. We're trying to remove this I. Don't worry, you see the I is going to disappear very soon. Let's go. So this multiplies this, you already know what multiplication is, so we'll just do it, we'll just jump some steps. So 2 times 4, that is 8 plus minus, minus 14i. Minus 14i, right? Yeah. And this times this plus 12, yeah, plus 12i. and this time this is minus 21i squared. Put that inside bracket so that it does not confuse you. Let me write it for yourself. 21i squared. So resolving this, we already know that 21i, we know that I squared is what? Remember, -1. So this is going to turn into plus 21. Remember, the negative sign, minus times minus plus. So we'll have 8 plus 21. This minus this will give you minus 2i. Then we'll simplify further. This plus this will give us what? 29 minus 2i. So that is for the numerator. Now for the denominator we know that, remember your difference of two squares now. Remember your difference of two squares. Instead of you multiplying it, you can see that this is difference of two squares. What does that mean? Let me just show you what difference of two squares means first. So imagine you have a squared minus b squared. Now instead of you, like there's no, you might be thinking about it. You must first know what a is or what b is before you can simplify this. No, you don't even need to know it. To simplify this, you have to just do this. This is difference of two squares. This is a square, this is a square. What is minus? Minus means difference. So this is difference of two squares. And the way we resolve that, or the way we simplify this, by basically carry one a, carry one b, make the sign plus. Yeah, and carry one a, carry one b, and pick the sign now, not change the sign. Pick the sign. That's not a minus b. So this is how we express the difference of two squares. This is the way to simplify the difference of two squares. If you see, you can even try it out. Multiply this by, open these brackets now, open these two brackets. You see, you still get this difference of two squares back. So it's not like we're changing it's not like I'm manipulating anything. It's just us simplifying it to the lowest form. So we have that difference of two squares now. So instead of us, so basically we're not going to go from this to this now. So in the numerator we have 29 minus 2i, and in the denominator now, if we're going from this to this, basically we're going to square the a and square the b, and then put minus in between them. So we're squaring the a. Our a here is 4 all squared, minus, remember I said you bring the minus, and your b here is what? 7i. So we'll square the 7i. So now simplifying this now, we'll have 29 minus 2i. This is not plus, so it's minus, over, what is this? 16 minus, so we're having I squared again, because if you open the bracket with this squared, that will turn into 7 squared I squared. So 7 squared is what? 49. I squared is what? -1. So that we have -49 inside this bracket. But now there's still minus here, so that will turn into plus 49. You can see now I've removed the I from the denominator by using conjugate method. So let me move this up. Alright, let me clean this. So from here now, what do we have as our answer? We have 29 minus 2i all over this plus this should give you about 65, right? 65. Am I correct? Am I correct? Yes, I am. It should give you 65. You might see your answer like this in the option, or they might just separate it out like this: 29 over 65 minus 2i over 65. The answer can be like this in the option, the answer can be like this. They still mean the same thing. So that is addition, subtraction, multiplication, and division. Now let me show you that trick I told you earlier about how to find I raised to power any big number or any small number, basically. So let me show you that trick. Goodness. You can clean this. Now, let's start with what is I squared. What is I raised to power 1? I raised to power 1 is I. I raised to power 1 will still give us I. Now, what is I squared now? I squared is what? Negative 1. We have already proved that before. So, now what is I raised to power 3? Or I cubed? Now, do you resolve this? We'll just bring back. Since the number is just small, we can just bring this back. Right? No, I told you that you split it into 2. We have I squared. From your indices, we can split it like this. I this, because if they have the same base and it's multiplication, if you're multiplying the same base, we can basically add the power together. So we have this times this. So this is going to turn into, for me, this is 2 plus 1. That's automatically 3i. That is if it's multiplication, or you cannot do it for addition and subtraction. That is, addition and subtraction is for log reading, not indices. So yeah, we have already split it like this now. So remember how I squared is. I squared is negative 1 times I. So hence, I cube is what? Negative I. So now, let's now do something like this now. They told you to find I raised to power 10 to 4. I raised to power 10 to 4. How do we start solving this now, you might ask? Well, since it is an even number always ends with an even number. You get? Because it's an even number, because you can see it can be divided by 2. So it's an even number. So since it's already an even number, there's no need for us to split it like this. If you remember, like this, so let us do I raised to power 4 first. It's an even number, so there's no need to start splitting it up to get I squared. So you can still split it up though, but that will just waste your time. Since it's an even number, we can just bring the roots of negative 1 inside back and give it the power. So we can just replace the I here with the negative 1. Root of negative 1. We know that square root is what? Raised to power. Square root means raised to power 1 over 2. So we'll change that here to minus 1 raised to power 1 over 2. And since this is here, we'll multiply it by 4. Normal indices. So 1 over 2 times 4, that is 2. And we already know from our basic multiplication that minus raised to power, any negative number raised to power even number will always give you a positive number, and any negative number raised to power an odd number will give you a negative number. So negative, this is going to give us plus 1 or 1. So our answer is 1 for I raised to power 4. So now, since this is an even number, you just bring back this root of negative 1, put it inside the brackets, and put 10 to 4. Remember, root is what? 1 over 2. So that's 1 over, sorry, root is what? Yes, root is raised to power 1 over 2. So if we bring that and put it here, let's just put another bracket. Put this. We know that we can, from indices, we know we can just multiply these two. That's the same thing we did here. So negative 1 all over 10 to 4 divided by 2. So what is this going to give us? It's going to give us what? 512. So 512, since it's still an even number, and a negative number raised to an even number is what? A positive number. So hence, this is equals to 1. Now let's do this one now, which is an odd number. Let me clean from here. Now for odd numbers, now you still use that method we use for I raised to power 3. So we have I raised to power 199. Now we'll first start by splitting it to make it an even, to get her to extract an even number from it. So that will be I raised to power 1998 times I raised to power 1. If we add this together, to still give us this back. So we have an even number here, so we can hence bring our root of -1 back in. -1 raised to power 1998. So you keep your I, just keep the I there like that, since it's an odd number. For odd numbers, you just keep the I there. So remember, root is what? 1/2. So this is 1/2 divided by this is what? So that is 1998 divided by 2 times your I. So this divided by 2 is what? That will give you 999, right? That's 8. So that's 999, yeah, times I. So since a negative number raised to an odd number is a negative number, always give you a negative number. So we have -1 times I. So hence I raised to power 999 is negative I. If you practice this a lot, like if you do it for any number, if you practice it, you'll be able to do it in your head even without writing on a book and even without writing it on paper. So that is the trick, and I think we'll be stopping here today. Before we stop, let me just teach you something that I did not teach you. Let me just move ahead from what I taught you yesterday. So let me just teach you just one new concept. Although there are many other things we're meant to do, this is just the basic. These are simple ones. Yes, we still have to do other forms of complex number. Okay, let me just introduce you to the different types of the different ways of representing a complex number. So since I started teaching you this complex number, we have been used to representing complex number in what we call a rectangular or Cartesian. What's that? Oh, yes, correct. Cartesian form. So I've been representing a complex number in Cartesian form. So that is what we have been doing, a plus b I. So everything I've been doing here, we have been having a plus bi. So that's what we call rectangular form. You remember that our example where we had z1 as 2 plus 3i. Even when we solved the answer, maybe we got like that time we got 1/2 plus 2i. This is also still rectangular method. Sorry, rectangular form. These are rectangular form. But now you go far. So the second type of way we can represent a complex number is using polar form. Polar form or circular form. So we can represent polar form, polar or circular form. So polar form is basically represented like this. Remember, we denote a complex number with z. So this is how the polar form is represented. We have r into bracket cos theta plus I sine theta. So this is how you represent a complex number in polar form. Don't worry, I'll teach you this one when next we have time, or I might send you a YouTube video that will explain from here. So This is the second way we can represent. This is the second way we can represent a complex number. But don't worry, you will learn it. You will learn that in time. You learn how to use it in time. These questions usually come in this format, in these two formats, in this format now, and the other one I want to show you now. So the third way we can represent a complex number is in exponential form. Exponential or Euler. They call it Euler, I think. Euler form. And this is how we represent it. Represent it using the same R, then E raised to power I theta. That's how we represent a complex number in exponential form. So these are the three ways in which you represent a complex number. We have the Cartesian form, which is your A plus BI, and we have the polar form, which is your R open brackets cos theta plus I sine theta close brackets. And we have your exponential form, which is your R e raised to power I theta. So these are the three ways in which you can represent a complex number. But just so that I can end the class now, let me just teach you how to find this R in these two these two these two types basically of how to represent the complex number. So we call that R the modulus. Okay, I didn't tell you this. When it comes to polar form, which is represented in this way, cos theta plus I sine theta, we call this R the is it modulus? Yeah, modulus or magnitude or magnitude, and we call this your theta the argument, like you're arguing with somebody, argument or amplitude, anyone. The word inside the book is amplitude, but they usually call it the argument or amplitude. Amplitude. So basically, how do you find the magnitude of a vector first? We do it by squaring. So let us say we have a complex number 2 plus 3i. I don't know why I always remember this, but anyhow. So to find the magnitude or modulus of this complex number, it's the same way you do it in vectors. Very, very similar. R is equals to square root of a squared plus b squared. Remember, in Cartesian form, we represent a complex number using this a plus bi. So your a here is what? 2. Your b here is what? This b, sorry, b squared. So we represent it. So these are to find your magnitude, which is r. So let's find the magnitude for this complex number. The magnitude of modulus. Even in vectors too, you can call it modulus. They usually call it modulus. So the modulus of this complex number is what? Root of 2 squared plus 3 squared. So that will give you what? 4 plus 9. That will give you root of 13. Now to find your argument, you use this method. This is how you find it. You use tan inverse of your b over your a, right? Yeah, I think that is it. That's it. Yeah, your b over your a. Yeah. Your b over your a. or you can even represent this using y. It's not a must, it must be a and b. Sometimes they use to represent Cartesian form in. They can say that your Cartesian, you can present it as x plus yi. Sometimes you might see it in textbook that they'll use, instead of a and b, they'll use x and y. So it's still the same thing, still similar to vectors in a way. So to find the argument or amplitude of this complex number, you will basically do tan inverse of tan inverse or arctan of 3/2. And if you punch your calculator, let me grab one. Where's my calculator? If you punch your calculator, you should get something about. Where's my calculator? There's it. Yeah. Fail. If you punch your calculator, that will be tan inverse of 3 divided by 2. That will give you 56.30 degree. But in complex number, we do not in complex numbers, we do not represent this theta in degrees, we represent it in radians. So if you convert this to radians, that will be 56, this 56.32. To convert to radians, you just multiply it by pi over 180. So pi over 180 times 56.30. That will give us the answer. So let me do that. 56.30 divided by 180. That should give us about 0.296 pi. That is your answer in radians. So we represent this theta in radians, not in degrees. Not in degrees. So if you wanted to turn this into polar form now, we already have our r, we already have our arguments. So in polar form now, this complex number here will be what? Root of 3 all into brackets cos this 0.296 pi plus I sine 0.296 pi. So that is how to represent, that's how to turn it from Cartesian form to polar form. So this is where I'll stop for today. I think you can do the same thing for it's just the same thing. You can still convert this into what they call it, exponential form. It's still the same method. You have to find your amplitude, you have to find your magnitude, and find your amplitude or arguments. Find your magnitude, find your arguments, then put it inside the formula, this formula, or the formula for your exponential form, which is basically z equals re raised to power I theta. Remember, your theta should always be in radians, not degrees, radians. So that is what I want to teach you today.